Hi everyone, and welcome back to CODEMAS. Today, let's briefly talk about the complexity. Complexity measures how much time and space we need to execute our algorithm. Big O notation is used to express the complexity, and there are some common classes of complexity, but some custom classes of complexity can occur, of course. It depends on our algorithm. And we always want the minimum class of complexity because it means that we require the minimum time and space to execute our algorithm. Let us just briefly take a look at classes of complexity, and in the following two videos, we will dive deeper into the time and space complexity separately. These are some common classes of complexity. So this is constant, logarithm, linear, this is n logarithm, and this is quadratic, exponential, and factorial. What means that some algorithm has, for example, big O of n complexity. If we have some array of n elements, it means that we need n places in memory for our array. So if n is equal 10, we will need 10 places in memory. If n is equal 100, we need 100 places in memory. If n is 1 million, we need 1 million places in memory. So this is an example of big O of n space complexity. Let us take a look at time complexity. If we have some for loop, here we have n iterations. So if n is equal 10, we have 10 iterations. If n is 100, we have 100 iterations, and if n is 1 million, we have 1 million iterations. So this is an example of big O of n time complexity. Sometimes our solution doesn't need to depend on our input n. N is some large element, and imagine that we need to find the sum of only first two elements in this array. So if n is 10, we will apply just first this line, and this line. So we will have only three steps. If n is 100, we will initialize first to first element, second to second one, and we will sum them. So we will have also three steps. If n is 1 million, we will have still only three steps. So this is an example of big O of 1 complexity. So as I mentioned, in the following videos, we will dive deeper into both time and space complexity. But for now, it's just important to be aware that whenever we're dealing with some algorithm and we are using some data structures, it's important to keep in mind that we need some time and some space for our algorithm. That's it for today's lesson on complexity. I hope this video helped to clarify what the complexity actually is and how to determine the class of complexity for some algorithm. In the following videos, we will continue diving deeper into complexity related topics. Until that, keep practicing and see you tomorrow with another topic.